The last speaker for the session is Harvinder Talwar of ICR, Indian Institute of Millets Research. He's going to be talking about stay grain QTL SCG3B, QTL associated with improved grain and stover yield under post-rainy sorghum growing conditions.
My name is Talwar. I'm working with Indian Institute of Millet Research in Hyderabad only. This work we did under a collaborative project funded by Australian Centre of Agriculture Research. And I am showing only phenotypic work, and the genotypic work will be covered by my colleague, Dr. Madhusudana, by a poster tomorrow. So my topic is we identified some key QTL for the stay green in post-rainy sorghum, and just explaining the results. So post-rainy sorghum is just grown on the residual moisture, and its prime target is to maximize post-tensis water use and water use efficiency. There are many traits already identified in the literature, but stay green is best characterized so far. So, but it is complicated and governed by multiple QTLs. So we need to identify the key stay green QTL. That was the major objective. So I'll skip this slide. And what we started with the material generated in ICAR-Indian. We got in two genetic background in R16 and R35, which are highly senescent lines. And lines were having single QTL or multiple QTLs. And we evaluated at 4 locations, and in India, it's post-rainy season growing regions. And then some evaluation of key adaptive traits like water extraction ability and transpiration efficiency is done mainly at lysimeter at ICAR by Dr. Vincent group. So this is the work. You can see this is the donor. B35 is the donor, and this was the recurrent parent in one background as S35, and the trials were conducted under well water condition as well as water stress condition, and we found that there is the green leaf area at maturity, which is a sort of a measurement of the stay green, is improved by 25% in well water condition and 100% in water stress conditions. But there is improvement under S35 background also. So, but it's not much as compared to R16. So from here it is confirmed even that stay grain 3B is the major QTL which is governing this green leaf area. Similarly, in the grain yield, you can see there is improvement in around 23% under well water condition and 16% under water stress condition. So under this genetic background, there is improvement under both the conditions, but there is a marginal improvement in S35. Similarly, in total dry matter biomass, so we got 11% in R16 background. So there is a genetic background effect is there. So then we conducted some trial under lysimeter in both at IIMR, but ICAR I'm showing major work from ICAR, the Vincent's work, and water sustainability and transpiration efficiency. You can see here again, stay green B is contributing a lot for water extraction ability in R16. There are lines which has more water extraction ability than R16, but much improvement is in S35, stay green 1. Then in transpiration efficiency as well, stay green B in both the genetic background is improving, but there is much improvement in R16. So with this, we come to the conclusion that stay green 3B is the major EQTL governing this, but stay green 3A also we have taken because they are located side by side on the chromosome 2. So then we thought let's try in this post-rainy adapted lines. There are 6 lines. 2 lines we did at our institute, and 4 is at ICAR. So I'm just showing the phenotypic results of these 2 lines. So these are the trials were conducted under, actually this is not still stable, but we some early generation of product we evaluated at only one location. This is just a preliminary data. This was in backcross 1 and F3 generations. The trials were conducted both in water stress and well water conditions. Then this was the line which is released from our institute, CRS4, and this is the result in the early generation of product. You can see there are most of the lines proved in both water stress and well water condition. In case of green leaf area at maturity, physiological maturity, and then there is a decrease in drought susceptibility index by 0.53 to 0.06, means there is improvement in the tolerance to the water stress conditions. There is a 15% improvement in grain leaf area under water stress and 22% under well water condition. Similarly, in the grain yield, there is improvement around 21% in water stress condition and 33% well water condition, and drought tolerance level also increased. Means by integration into Rabi adapted lines, we have an increased both grain yield as well as improving its drought tolerance. Similarly, in the stover yield also increased by 35% under water stress conditions. So this is the second Rabi adapted line. Here also there is improvement, but here in this line there is not much improvement in the grain yield, but there is improvement in green leaf area. Similarly, stover yield, there is improvement at 83%, means it almost become double in this background. So in summary, stay green 3 is the QQTL associated with the stover as well as the grain yield post any sorghum. Stay green 3B is associated both with the improved transpiration efficiency and water section, but there is a definitely genetic background effect is there. So from the last part where we progressed into the Rabi adapted lines, so we found that it has a potential to enhance the post-holding drought tolerance, but we need to confirm it by conducting multi-location evaluations. Thank you very much.